Welcome back. Gabriel's horn is a shape created by rotating the function y equals 1 over x around the x-axis and starting at x equals 1 and going to infinity. So if we were looking for the volume of Gabriel's horn, our disk looks something like this. And this is how I always teach my students. We've got a width of delta x. We've got a radius of our disk. The radius is based on y equals 1 over x, which means that the volume is pi r squared delta x. And if you're doing Riemann sums, pi 1 over x sub I squared delta x. So that means that the volume of my function is the integral from 1 to infinity of pi dx over x squared. And of course, we've got an improper integral here. So we're going to take the limit as b goes to infinity of the integral from 1 to infinity of pi dx over x squared. The antiderivative of pi over x squared is negative, let me write in limit as b goes to infinity. It gets a little tedious, and sometimes I forget to do it. Of pi times negative 1 over x from 1 to b. And I already slipped up there. That should be a b because we've switched to an improper integral. So we get the limit as b goes to infinity of minus pi over b plus pi over 1. As b goes to infinity, we see that that goes to 0, which means that this volume is equal to pi. We have an infinite horn with a volume of pi. Okay, so that's interesting. Why do we care? Let's talk about the exact same horn. But this time, let's find the surface area of the horn. I still have a change in x, but the surface area of this disk is 2 pi r, where r is equal to 1 over x, which means that the surface area is the integral from 1 to infinity of 2 pi dx over x. And when I change that to an improper integral, we go from 1 to b of 2 pi dx over x. But this is the limit as b goes to infinity of 2 pi natural log of x from 1 to b. This is the limit as b goes to infinity of 2 pi times natural log b minus natural log 1. Of course, we all know that natural log of 1 is 0, which means that this is infinite. And there is what is interesting about Gabriel's horn, is that we have this shape. And it has a finite volume but an infinite surface area. And that is pretty darn fascinating. All right. Hope you enjoyed this, and thanks for watching.